One type of math question that is guaranteed to show up on the SAT is exponential change. You need to know the formula, how to apply it, and how to interpret it so that these questions won't trip you up. Got a few minutes? I can help you. Hello, I'm Janie. The SAT and I are like old friends. We met way before social media existed, lost touch after high school, and reconnected years later. We've seen each other go through major changes several times, but I know this friend really well. And I have some useful tips, strategies, and knowledge about the SAT that I can share with you. Okay, exponential change. Let's start with the formula. I know that SAT provides you a formula sheet, but the truth is you need to know a few more formulas than the ones shown there. One of those is exponential change. This is the formula. I know, it looks a bit intimidating, but I prefer to write it this way. That way I don't have to remember what all the letters represent. The total represents the population, money, or radioactive substance at any given point of time, because remember that this is a function of time. The initial amount refers to the original amount of the population, money, or radioactive substance. The rate of increase or decrease, if it's greater than 1.0, that indicates an increase, and less than 1.0 for a decrease. For example, if you have a 20% growth, what it really is saying is that you have 120% as a decimal is 1.2. If you have, however, a decrease of 25%, then really the rate is 75%, and as a decimal, 0.75. With the time is a number of time intervals, and that could be as small as seconds or minutes, or even months or years, depending on the situation. Sometimes it may be necessary to convert from months to years or vice versa. Some of the questions are about being able to interpret the formula. So you really don't benefit from a calculator here. You just have to know what each number represents in reference to the real life situation that is described in the problem. Another type of question is where you have to apply the formula. You have to know what numbers to plug in the formula and then just solve it. And a third type is where you do have to apply and interpret the formula, but the exponent, the t value, is not just t, it's t multiplied or divided by a number, and these are a little bit trickier. Now let's work through an example of each. The function models the value in dollars of a certain bank account by the end of each year from 57 to 72, where x is the number of years after 57. Which of the following is the best interpretation of f of 5 is approximately equal to 243 in this context? So first of all, we have to determine what the 5 represents. The 5 we know is the value of x, and they tell us that x is the number of years after 1957, which means that we have 5 years after 1957, which, by the way, would be the year 1962. Now we look at the rest of it, which says that it is equal to 243, and we know the function is the value in dollars of the bank account by the end of the year. So that would mean that there are $243 in the bank account at the end of that year. And the choice that says that in 1962 there are $243 is B. The model estimates that at the end of each year from 2015 to 2020, the number of squirrels in a population was 150% more than. Here, the 150% more than is tricky because that means that the prior year there was 100%, and the year after there was another 150%, which means the rate was really 250%. And as a decimal, that's 2.5. So we can go ahead and eliminate the two options that are wrong. We continue reading, and then it says that at the end of 2016, and since we started at 2015, that means the interval of time is just 1 year. So the exponent would be 1. And it says that there were 180 squirrels in the population. That's the total amount after 1 year. So that would be the value of n, not the initial amount. So we can cross out these two options, and we know that the answer is B. The function gives the number of bacteria in a population t minutes after an initial observation. How much time in minutes does it take for the number of bacteria in the population to double? The key word here is double. That means the number in the parentheses must be a 2. And for it to actually double, the exponent would have to be 1. So that 2 to the first power is just doubling. And if we look at the equation, it says that it has a 2 with a power of t over 410. So for this to be doubling, that means that t over 410 has to be equal to the 1 so that they have the same exponent. And if we make that equivalency and we solve for t, we can see that t would have a value of 410. So as you can see, once you know this formula and understand it, the problems become relatively simple. If you'd like to see more examples worked out or any other type of problem, let me know in the comments.